Let me say something that's going to sound completely wrong the first time you hear it. The Big Bang never happened. No explosion, no first second, no moment where everything came out of nothing like some cosmic magic trick. I know that's the exact opposite of what you were taught. It even sounds like clickbait coming out of my mouth. But stay with me for a few minutes before you decide I've finally lost it. If this video messes slightly with your common sense in a good way, do me a favor and subscribe now. If it doesn't, you can always unsubscribe later and pretend this never happened. Fair deal. Now here's the important part. I'm not denying the Big Bang Theory. I'm not saying the universe isn't expanding. I'm not saying the leftover heat from the early universe doesn't exist. All of that is solid. We see galaxies moving apart. We measure the faint glow of ancient radiation everywhere we look. The math works beautifully. The mistake is not in the data. The mistake is in the picture we tell ourselves. Most people imagine the Big Bang as a kind of explosion. A tiny dot blows up and becomes everything. Space, time, matter, energy, all bursting into existence at once. That picture is burned into textbooks, documentaries, even cartoons, and it's wrong. Not slightly wrong, deeply wrong. The real Big Bang Theory says something much calmer. Space itself is stretching. Not galaxies flying through space, but space growing between them. If you run that stretching backward, the universe gets hotter and denser. About 13.8 billion years ago, everything we can see was packed into a very small region. Hot, dense, violent, yes, but not a creation event. So where did the idea of a beginning come from? From pushing a theory too far. When physicists use Einstein's theory of gravity and rewind the universe all the way back, the equations start misbehaving. Numbers shoot to infinity, density becomes infinite, temperature becomes infinite, space and time collapse into a single point. That point is called a singularity. And here's the key idea most people miss. A singularity is not a physical object. It's not a thing that exists in nature. It's a sign that the theory has stopped working. It's math screaming for help. We've seen this before. Use simple physics to describe extreme situations and you get nonsense. Infinite values, broken predictions. That doesn't mean reality is infinite. It means your tools are wrong for the job. The Big Bang singularity is exactly that. General relativity, as powerful as it is, ignores quantum effects. And near the very early universe, quantum effects are not optional. They run the show. So when the equations say beginning, what they're really saying is, you need better physics here. The beginning isn't real. The breakdown is. And that's where the real story starts. So what happens when we use better physics? When we stop pretending that space and time are smooth and gentle all the way back to the start and admit that quantum mechanics has something to say? The singularity disappears, not fades away, not gets pushed somewhere else. It simply isn't there anymore. Quantum mechanics refuses to allow infinities. It doesn't let you squeeze things forever. There's always a smallest meaningful scale. Try to pin something down too tightly, and nature pushes back. Uncertainty isn't a bug, it's a rule. Now imagine applying that idea to the entire universe. As you rewind the expansion, space gets smaller and hotter, but it doesn't collapse into a point. Instead, space-time itself starts behaving like a quantum object. Fuzzy, unstable, more like a wave than a surface. The smooth picture breaks apart before infinity ever shows up. This is where a lot of people feel uneasy, because we're used to thinking of space and time as solid things. They feel real, they feel permanent. But physics keeps telling us they're not fundamental. They're more like temperature or pressure. Useful descriptions, not basic ingredients. One possible outcome of this quantum behavior is something called a bounce. The idea is almost embarrassingly simple. Before our expanding universe, there was a contracting one. It shrank down to a very small size, but not zero. Quantum effects kicked in and stopped the collapse. Gravity, instead of pulling inward, became repulsive for a moment. The universe bounced and began expanding again. From our point of view, looking backward, that bounce looks exactly like a beginning. But it isn't. It's a turnaround. Is this definitely what happened? No. Anyone who says they know is guessing. But the important point is that the singularity is gone. The beginning is no longer forced on us by the math. There's another idea that's even stranger. Maybe there was no before at all. In some approaches to quantum gravity, time itself changes character near the early universe. It stops behaving like time. It starts behaving like space. When that happens, asking what came before the Big Bang becomes meaningless, not mysterious, meaningless, like asking what's north of the North Pole. There's no wall, no edge, no first moment. Time simply closes off smoothly. This is incredibly hard to picture because our brains are built to think in terms of cause and effect, before and after. But nature doesn't care how our brains work. And then there's inflation. Inflation says the universe went through a short burst of rapid expansion early on. That idea explains why the universe looks smooth and uniform. It explains the tiny ripples that later became galaxies, and it works frighteningly well. But inflation comes with a twist. In most versions, inflation never fully stops. It ends in some regions, creating hot expanding universes like ours, but continues in others. Those regions keep growing, spawning more regions, forever. Each region that stops inflating has its own Big Bang. Our Big Bang wasn't special. It was local. In that picture, there is no single beginning of everything. There are countless beginnings happening again and again inside a much larger structure that doesn't start or stop in any simple way. And suddenly the phrase "the beginning of the universe" starts to feel like the wrong question entirely. Now, when people hear this, they usually lean back and say, okay, this sounds clever, but isn't this just speculation stacked on top of speculation? Bounce models, strange time, endless inflation. It starts to feel like we're making stories because we don't like the idea of a beginning. That reaction makes sense. Physics should be skeptical of itself. But here's the thing. The idea of a literal beginning is not conservative. It's desperate. A singularity is not a clean answer. It's a failure. It's a place where the equations stop making predictions. And a theory that predicts its own breakdown is telling you, very politely, that it's not the final word. Physicists don't get uncomfortable with strange ideas. We get uncomfortable with broken ones. Now let's talk about eternal inflation for a moment, because this is where the story really changes shape. Inflation was originally proposed to fix problems in the early universe. Why space looks nearly flat. Why distant regions look similar even though they shouldn't have had time to talk to each other. Inflation solves those problems almost too well. But when you look closely, inflation doesn't like to turn off. The field that drives inflation is affected by quantum noise, tiny random fluctuations. And sometimes, in some regions, those fluctuations push inflation to continue instead of ending. Those regions grow faster, much faster. So fast that inflation keeps winning the race. The result is a strange picture. Some regions stop inflating and become universes filled with particles, stars, and time as we know it. Other regions keep inflating and produce more regions that do the same thing. This process never ends. Our universe is one bubble in that process. Our Big Bang was the moment inflation ended locally, dumping energy into matter and heat. That's what the Big Bang really is, not creation. Reheating. And if that's true, then asking what happened before our Big Bang is like asking what happened before a raindrop formed in a cloud. The cloud was already there, bigger, older, complicated. Now there is a theorem that says even inflation can't be extended forever into the past. Fine. But that doesn't bring back the singularity. It just tells us there's some boundary where our current description stops working. And that boundary doesn't look like a beginning. It looks like another place where quantum physics takes over. No fireworks, no creation event, just another handoff between descriptions. This way of thinking solves a problem people rarely talk about out loud: initial conditions. In the old picture, the universe starts in a very special state, just the right density, just the right smoothness, just the right tiny bumps, balanced on a knife edge, and nobody can explain why. In eternal inflation, that question fades away. Everything that can happen does happen somewhere. We're not special because the universe was tuned for us. We're here because regions like ours are the only places observers can exist at all. That idea makes people uncomfortable, but discomfort isn't a physics argument. What matters is this: the more we learn, the less the universe looks like something that began, and the more it looks like something that simply exists. Not forever in time, but deeper than time. Time itself starts to look like a local feature, not a global rule. And once you accept that, the Big Bang stops being the start of everything and becomes something much more modest. At this point, there's usually one last objection left, and it's an honest one. If none of this can be directly observed, if we can't look before the Big Bang, or see other regions inflating somewhere else, then how is this still science and not just storytelling with equations? The answer is uncomfortable but important. We don't test deep theories by watching everything they talk about. We test them by checking whether the pieces we can see fit together without breaking. General relativity passed every test we threw at it until it predicted singularities. Quantum mechanics passed every test we threw at it, but refuses to allow infinities. When two theories clash, reality doesn't choose sides. Our understanding is what's incomplete. The reason physicists take these ideas seriously is not because they're pretty or dramatic. It's because they remove contradictions. They clean up places where the math was clearly lying to us. Inflation predicts patterns in the ancient light we see across the sky, and those patterns show up exactly where they should. Quantum physics explains why matter is stable, why atoms exist at all, why the universe doesn't collapse instantly. When you extend those ideas carefully, the beginning keeps slipping away, and that should tell you something. There's also a personal side to this that rarely makes it into textbooks. When people first started thinking seriously about black holes, many believed information was destroyed forever. The equations seemed to say so, but that conclusion felt wrong. Not emotionally wrong, structurally wrong. And after decades of work, it turned out the equations were misleading us again. Information wasn't destroyed. The classical picture had simply been pushed too far. The Big Bang is the same kind of mistake. A theory working beyond its limits, producing nonsense, and tempting us to treat that nonsense as truth. When you hear the universe began, it feels comforting, clean, human, stories like beginnings. But physics doesn't owe us a story arc. What it gives us instead is a picture where time is not fundamental, where what we call the beginning is a transition between phases, where the universe doesn't come from nothing because nothing is not a physical state. Our universe has an age. That part is real. About 13.8 billion years since our local expansion began. But the structure that produced it doesn't have an age in the same way. Asking how old it is might be like asking how old a number is. The deeper we go, the more the question changes. Not when did everything start, but why do our descriptions stop working in certain places? And every time that happens, history shows us the same pattern. There is more underneath. So when someone says the Big Bang never happened, what they really mean is this: the universe did not spring into existence from nothing at a single moment in time. That picture is a shortcut, a misunderstanding, a placeholder we've outgrown. The Big Bang was real as an event in our region. It was hot, dense, violent, transformative. But it was not the birth of everything. It was a change in how the universe behaves. And the universe, as far as we can tell, doesn't need a starting gun to exist at all. There's one more thing I want to slow down on because this is where intuition really fights back. Time. We treat time like it's the stage everything happens on. Always there. Always ticking. But physics keeps whispering the same uncomfortable idea. Time might not be basic. In everyday life, that sounds absurd. Yesterday happened. Tomorrow will happen. End of story. But in the equations that describe gravity and quantum mechanics, time doesn't behave like a universal clock. It behaves more like a feature that shows up under certain conditions and fades under others. Near the early universe, those conditions break. When space-time becomes extremely small and energetic, the usual idea of time flowing smoothly just doesn't hold together. Cause and effect blur. Before and after lose their sharp edges. It's not that nothing happened, it's that our language stops working. This is why phrases like "before the Big Bang" are dangerous. They sneak in assumptions we're not allowed to make. They assume time existed in the same way it does now. But that's exactly what's under question. Think about temperature. At the level of individual particles, temperature doesn't exist. It only makes sense when you average over many particles. Time may be similar, useful, real in practice, but not fundamental. So when we rewind the universe and hit the quantum regime, asking for a first moment might be like asking for the temperature of a single atom. It's not wrong because we don't know the answer. It's wrong because the question itself doesn't apply. This flips the usual story on its head. Instead of the universe beginning and time starting, it may be that certain arrangements of the universe give rise to time. Our expanding, cooling universe is one of those arrangements. Time flows here because the conditions allow it. That means the Big Bang wasn't the start of time. It was the moment time became a good description. And that's a very different idea. Now, none of this is settled. Anyone honest will tell you that. We don't yet have a complete theory that merges gravity and quantum mechanics. We're still circling it, probing it, arguing about it in chalk-filled rooms and long papers nobody finishes reading, but the direction is clear. Every serious attempt to go deeper removes the beginning instead of confirming it. Every improvement replaces the singularity with structure, with process, with something that doesn't need a magical start. And that should make you pause, because science doesn't usually erase beginnings unless they were never really there to begin with. The Big Bang, as people imagine it, survives mostly because it's simple and dramatic. It fits on a timeline. It gives a clean answer to a messy question. But simplicity is not the same thing as truth. The universe has never shown much interest in being simple for our convenience. What it shows instead is consistency. And consistency points away from creation events and toward transitions, away from absolute starts and toward deeper layers that don't care about our storytelling instincts. So when you hear that the Big Bang never happened, don't hear denial. Hear refinement. What didn't happen was the universe coming from nothing. What did happen was our region-changing state, cooling, expanding, becoming a place where atoms, stars, and questions could exist. And that change was dramatic enough to leave echoes we can still measure today. The beginning we talk about is real in the same way a sunrise is real. Something changed, something became visible. But the sun didn't begin to exist when it crossed the horizon, and neither did the universe when our expansion began. So let's come back to the title, because now it should sound a little different. Why the Big Bang never happened doesn't mean the early universe is a myth or that cosmology got everything wrong. It means the story we tell ourselves is outdated. If by Big Bang you mean the hot, dense phase, when our universe was young, then yes, absolutely, that happened. We've measured it. We've mapped its leftovers. It's one of the strongest results in all of science. But if by Big Bang you mean a moment when everything began, when time switched on and the universe appeared from nothing, then no. That almost certainly did not happen. That idea came from taking a beautiful theory and forcing it past its breaking point. The deeper picture is quieter and stranger. Our universe looks like a local event inside something much larger. Inflation ending in our region, energy turning into matter, time becoming meaningful. That's what our Big Bang really was. Not a birth, a transition. And once you see it that way, a lot of confusion melts away. The panic about what came before, the need for a first cause, the discomfort with an eternal structure. These are human worries, not physical ones. Physics doesn't ask for a first page. It asks for consistency. And consistency keeps pointing to the same place. No singularity, no creation event, no sharp beginning where the rules suddenly appear out of nowhere. Just layers. Each layer working well where it applies and quietly stepping aside where it doesn't. General relativity describes space and time beautifully until quantum affects matter, then it bows out. The Big Bang singularity was never a discovery. It was a warning label. Once you respect that, the universe stops looking like something that started and starts looking like something that simply is. That doesn't make it less amazing. If anything, it makes it more so. A universe that doesn't need a beginning is not cold or empty. It's confident, self-consistent, not fragile. And it leaves us with a humbler role. We're not witnesses to the moment everything began. We're observers inside one chapter of a story that doesn't need an opening line. So the next time someone tells you the universe exploded out of nothing 13.8 billion years ago, you'll know how to translate it. Something important happened then, yes, something measurable, something real, but the Big Bang as a beginning of all things never happened, and that's not a loss, it's an upgrade. Before we end, let me say something slightly uncomfortable, but honest. None of this is meant to make the universe feel colder or pointless. People hear no beginning and somehow translate that into nothing matters. That's not what physics is saying at all. If anything, it's saying the opposite. A universe that doesn't pop out of nothing is sturdier than one that does. It doesn't rely on a miracle. It doesn't need a special moment where the rules suddenly switch on. It works because it works. Everywhere it works, even where our understanding doesn't. And that should actually make you relax a bit. Think about it. If everything depended on a single fragile starting moment, One wrong digit in the equations and nothing exists. But if reality is layered, if beginnings are local and not absolute, then existence isn't balanced on a knife edge. It's robust, forgiving, hard to break. That's a better universe to live in. It also changes how you see time. Your past didn't start at the Big Bang any more than your life started at sunrise. Things were happening long before you showed up, and they'll keep happening long after. That doesn't make your moment smaller. It gives it context. Your atoms were cooked in stars. Those stars formed because of tiny ripples in an early hot universe. That hot phase came from inflation ending nearby. Inflation came from deeper physics we barely understand. None of that needs a first spark. It just needs consistency. And consistency is what physics actually trusts. Now, I know some of you are thinking, okay, this all sounds deep, but does it matter? Does it change anything about how we live? Or is this just mental gymnastics for people who like chalkboards? It matters because it trains you to be careful with stories. The universe keeps teaching us the same lesson. Simple pictures are useful. They're not sacred. When the picture breaks, you don't defend it, you replace it. The Big Bang as a beginning was a picture. It did its job. It helped us build better questions. And now those questions are pointing beyond it. That's progress. So next time you hear someone confidently say, "Everything began at the Big Bang," don't correct them like a robot. Just smile a little. You know what they mean. And you know what they're skipping. They're skipping the part where physics admits its limits. They're skipping the part where deeper ideas take over. They're skipping the most interesting part. And if you've stayed with me this long, you're clearly not here to skip the interesting parts. If you enjoyed this, subscribe. Not because it helps the algorithm, although it does, but because your brain clearly likes being gently bothered. And we do that here, slowly. Without rushing, without pretending we know more than we do. Physics unrushed. No explosions, no fake beginnings, just ideas that survive being pushed too far. And if the Big Bang never happened the way we were told, that doesn't make the universe less beautiful. It makes it honest. And honestly, that's way better.